Welcome back. So in the previous video, I mentioned using a named pipe to send the data or the stream from FFMPEG to another instance of FFmpeg and then using that stream to live stream. First, let's talk about what a named pipe is. We can get an idea of what it is if we look at the section 7 of the pipe man page, or pipe 7. And over here it gives an idea of what it is. It tells us that we can use the program make FIFO. There's also another program called make node or make node. It's MKNOD, and we'll get to that one also. And we can look at other man pages, but this is just a brief overview. But what I want to cover in this is the pipe capacity. Since Linux 2.6.35, and this is a Linux 6 system, so we're going to be using this, is we're going to be checking out this proc sys fs pipe max size, which it says by default is 1 megabyte. So if we go and view that, lo and behold, it's 1 megabyte. What I've been having an issue with is the size of the pipe not holding the data that I need. What's been happening in my testing of using this is that if the data doesn't flow effectively from the second instance of FFmpeg, or does not start correctly, then it gets a buffer overflow essentially. And there's also some other buffering issues that I've been running into with the microphone also. So let's get a look at the code I've written. So let's take a look at this script. So I'm leaving the stream key in there, even though this instance we are not using it. And so I'm using the same basic file that I used in the previous video. That's why I have the video sources here, and basically that's what I'm using. I'm using this temp pipe file as a input device, and we have the input screen frame rate of 30. We're using 1080p, the 1920 by 1080 for the output resolution, and frame rate of 90. I've been playing around with the frame rate, so that may not be critical. This been trying to figure out how to clear that buffering issue. We're using the .re, which is the real-time flag. Probe size I have at 5 megabytes. I may need to adjust that as this script works, but not as efficiently. And here's where we input that FIFO pipe. And here what I'm doing with this one is no matter what the input device is, I'm using the microphone just because all the instances I've been using is all going to rely on the same microphone. So I don't need to keep having the different scripts that feed into this FIFO pipe handle that audio, with the exception of the video file one, which I will probably do on the next live stream. So this is just the standard audio filter that I was using previously. It's not ideal, but just some testing. And here's where I was trying to get the bitrate buffering corrected. Here we're using the H.264 video codec. We're still using the format for FLV just because that seems to work the best. The output frame rate from what we had before. And here is for the, again, trying to get that bitrate up. Trying to set this, been playing around with that and different items. This preset ultra fast, again, is trying to get that bitrate up. A lot of this testing I've been doing with this method has been focusing on getting the bitrate up, because initially I thought that YouTube complaining about that is why I was getting choppy videos, but then I noticed that with other streaming sources like OBS, I was getting the same thing. I want to try to get the bitrate up as high as I can, but I'm leaning away from that right now in testing this. I'm scaling it back up to that 1920 by 1080 from whatever the size that comes in is, hopefully at 16 by 9. And normally you would send it to the stream, but I'm sending it to a file for this testing purposes. And these are just some items that I was testing earlier on with different flag configurations. So that's the file that takes it from the stream. So this is the script that takes it from the FIFO pipe and sends it out. Next, let's take a look at some of the other scripts to feed into the FIFO pipe, and we'll look at the standard one that we've used, the X11 grab one. Again, now this is the output pipe as temp pipe. The screen number and the display number, if you have any confusion with that, take a look at the previous video where I dealt with X11 grab. The input frame rate, again, I was playing around with trying to get that buffering together. I had it down to 1 frame per second and that was working. I may change that around. The input and output resolution are 1366 by 768, and that is the resolution that I have on this machine. If I only want to do similar to what I'm doing right now and only record part of the screen, I would adjust that, and I don't recall if I included that in the X11 video, but I will go back to it and cover that later on. And very similar, FFMPEG.RE, probe size. Here we're using the format of the X11 grab. The video size is that input resolution, and the input device is the display number dot the screen number. This I've, again, playing around with the max rate, the buffer size, and the min rate, and the Q max. These are all items I've been playing around with. This script has worked the best so far. The rate is the output screen rate. I am using no audio. I'm sending it out as an AVI file, again, just out of testing, and using that preset ultra fast. The -Y I added because since the FIFO pipe exists, since that file exists, I need to get it to not ask me, because that was part of the issue, is that time between getting the scripts running at the same time, they had a lag because it asked for that input. And then the output file is output pipe. And these are just some items that I was playing around with. I was trying to get the format as FIFO, which does not work for both the input and the output, and it wasn't making much of a difference. So let's take a look at the Make FIFO man page. It could be as simple as Make FIFO and the name. You can change the mode. You can set it security. You can set other things, but for what I've done is just used it with just the name. And the Make FIFO 3, let's just take a look at that, is if you're using the C standard library, and that may come into play because most of the FFMPEG items can be done in C, so that may be where this series or this project eventually goes to. So let's take a look at the named pipes that I've made so far. And we're going to use them with the -L flag, and there's 2 of them here. There is one that I made earlier on called temp, and then I wanted to give it a little bit better name, and I called it temp pipe. These are both stored here as part of the regular file system. I have done other tests where I created it in the /run directory, which is the temporary RAM disk that's created, and I got about a 10% difference in that. Again, if anybody wants to see a video on me doing this testing, let me know and I'll show you how I went through it. So let's make another temporary pipe just so we can see how it's done. Make FIFO, and we'll just keeping the same temp 2, and hit enter. And we do not need to be root to make this file because we're just creating it in our own home directory. It's not going in the /dev. If I made it in the /run directory, then I would need to be root and change the permissions. So let's go see what the default permissions are, and there they are. Is the user or the owner can read and write, and everybody else can anyone in the group can read, anybody else can read. So this is good if you're the only user using it. Otherwise, you can use chmod, and let's just change everything to, I believe it's 6. Yeah, it's a great number to put there, and temp 2. And then we'll take a look at it. And now everybody can read and write to temp 2. Don't need temp 2 anymore, so we'll get rid of that. And we'll give these scripts a test. Okay, let's see if I screwed anything up. So in one tab, I am going to run the Y5A. And in the second one, I'm going to run the Y5X11. Let's see what happens if I start the Y5A first. And it's running. It's running with a bitrate of 2500, but the speed is still less than 1 over here. So the bitrate is going down, but again, I'm not overly concerned about that anymore. And the speed is going up, and this is the X5. This is creating this test 5A for FLV file. And over here, the speed is 1, and that seems to be okay. So it's somewhere in between. So I'm going to go ahead and quit here. And that should have closed this. But there's probably still getting some of the buffering in. And as you can see, the speed did finally line up, but it has not gotten any more frames. And it may be getting some of the audio, so I'm going to quit there. Oh, and I apparently forgot to comment out that. So it's trying to run that line. This is the video that I did. I'm going to cut out most of the audio, but I'll let you hear this part here just so you can see that this microphone isn't that great. It's still less than 1 over here. So the bitrate is going down, but again, I'm not. I had mentioned in the previous video that I would like to schedule a live stream. And as I'm looking at my notes here, I will show you the make nod, which make FIFO is just a version of make nod, and we are using the FIFO pipe, so it's no longer planning. It's been recorded, because by the time I finish this, it's recorded. The last video was published 2 days ago. I asked about the live stream. I haven't gotten any responses, so I'll put a poll on the community tab if anyone has any input on when the best time to live stream is. This video has been recorded. So the one last thing I want to show you is the man page for MakeNod. And as you can see, it can be used for different types of block character devices. So you can use it to make a block device, a buffering device, a unbuffered character device, or like we did here, we just created a FIFO pipe. So it just uses this one item. So you can, if you're using it to make a block device, like used for like a hard drive, or a character device, like something like DevNull is a output character device, but we just are using the FIFO device. So anything else, just go ahead and throw those in the comments on how you'd like this project to go forward. Any ideas, any experience. Otherwise, thank you for watching. You have a great day.